Hi, my name is Yohann, and today I'm gonna show you my project I did during my internship at the Audio Analysis Lab. So I'm a French student, and during my formation I had the opportunity to work for Matt Christensen, which is the head of the Department of Multimedia Technology of the Aalborg University. My project was to work on the guitar transcription. So the idea was to explore the two papers Matt Christensen and Jacob Moller-Enrich did during several years, which are the WASPA and ICAS paper. These two papers talk about a physics model for fast estimation of guitar string, fret, and plucking position. Their proof of concept show that their model is able to create a classifier which is able to predict in real time or very fast the string, the fret, and the plucking position when you play on your guitar. The proof of concept show that they reach the error of 1.5% on their dataset. My project was to use this work to create an audio plugin like a VST file to apply this method in real time and allow some users to use it as kind of guitar tab transcriptor. So if you want more detail, you can check the source and these papers which explain everything and give you the MATLAB code. My job during this internship was mostly to understand this MATLAB code and to implement it in C++ with the API Juice to create a VST plugin to use it into a DAW. I'm gonna show you my plugin. So here is my plugin. I won't go into detail later, but now I just want to show you how it looks like when we play the same test as we can see in the paper. So here is the audio file that Jacob used in this paper. So yeah, you can listen to it. So basically this is a response of the plugin. You have different parameters on these plugins. So the first parameters are parameters relative to the classifier. So you have padding, resolution, number of harmonics. If you go into detail with the paper, you will understand what does it mean, but it's just for experimentation and maybe later to improve the plugin. So we can play the song and see what it will do. So as you can see, it works as the paper show with the same results. There are other parameters in this plugin, which are the plucking resolution and the distance from the bridge. We can activate the plucking position and change these parameters. So the resolution is in centimeters and the distance is where you want to search for plucking position. Less it is, faster it is. So if we activate the plucking position and play the audio file, you can see that it will determine the position. So if you look at the paper, you will see the same result with the plucking position which increase in the test. There are other fields for some parameters. So in fact it's pretty simple. The model is based not on record but on string parameters and features. So you can search the datasheet of your guitar string on the net and find this kind of parameters. Globally, the string parameter is something you will find very easily. Tension is sometimes said. For the other parameters, normally you don't have to change it, and the chord diameter is something that you can measure or find on some website or maybe try by yourself to improve the model and to fit the model to your guitar. So if you have, for example, some 9 to 42 strings, you have to change this kind of parameters and adapt, in fact, these fields to your guitar. I also add a compressor. Basically the idea is that when some guitars are noisy, the signal is detecting some onset and overplaying, in fact. So to avoid this, in Udo you can load the nose gate, but in standalone application, that the plugin works also in standalone application, you are not able to do this. So I add a compressor which can work as a nose gate if you parameter it like it is at default, but also like a compressor if you want. The main idea behind that is that for the detection, sometimes compress a bit the signal is better and help a lot to make good detection. So here you can see that if I use a big threshold, you can see that there is no small signal, only the peaks. I can also try to make some compression with these parameters. You will see that the peaks will be a bit affected by the compressor. There is the release time and attack time, which are commonly parameters of compressing, and the alpha is the reaction time of level changement, so the speed of reaction of this atom. So as you can see, there is also an onset threshold. So it's for some guitar which are different behavior from other, and maybe as default the plugin will make some over detection or under detection, and the threshold can help you to adapt to your situation. So for my situation, lower threshold is maybe better for this kind of playing. You can also change the font size of the tab to adapt to what is better for you. So now I will show you the plugin in real conditions. So here is some audio where I play a solo. The idea is to transcribe the note of the solo in real time. So the plugin is set up to work with 9.42 strings. As you can see, it transcribes the note in real time. Everything is set up to work well in real time and as fast as it's necessary. We have also the plugin position. So it's a bit to sum up everything. So you can see that the font size has been changed, the threshold has been adapted. I will play a bit with the compressor to show you the changement it applies when I activate it or not. I also like to mention that if you change the value in the parameters, you have to reload the model, not for the cursor but for the field of chord diameter, string diameter, and the other else. Now we can also try to add some playing stuff like bends, legato, plugin techniques, and everything like that, which help for real tab transcription. Also would be a great project to try polyphonial detection and try to make polyphonial transcription to predict chord and different note play at the same time. Maybe improve the onset detector, and if it's possible, the classifier. So it's a step-by-step project, and I think there is a lot again to do on this project, but this is where we are at the moment. I really want to thank you, Matt and Jakob, for helping me to do this project, and I hope you enjoyed this video. Goodbye.